The acid is a substance which can accept a pair of electron, where base is a substance which donates a pair of electron. What is Kc? It is nothing but a molar concentration of the product divided by molar concentration of the reactant. So what is the Kp value here? Kp is nothing but a Kc into RT raised to the power of delta Ng. Delta Ng value is nothing but a number of moles of the product divided by number of moles of the reactant in the gaseous state. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called equilibrium. Under this unit, we have discussed about the electrolytes and its types, and also we have learned about the theories of acids and bases. In that, we have understood about only two theories. One is Arrhenius theory of acids and bases, and also we have understood about the Bronsted-Lowry theory of acids and bases. In addition to that, we also learnt about what is a conjugated acid-base phase, what is a conjugated base for an acid, and what are the amphoteric substances also we have learnt. Today, let us move on to the next topic of this unit by understanding the last theory of acids and bases, that is Lewis theory of acids and bases. In addition to that, we are also going to solve the sum of the numerical based upon the equilibrium constant. Okay. First, we will see what is a Lewis theory of acids and bases. According to the Lewis, the acid is a substance which can accept a pair of electron, where base is a substance which donates a pair of electron. So, as we have learned about the two theories which is already, one is Arrhenius theory of acids and bases. According to that, he say that acid is a substance which can donate the H plus ion, where base is a substance which can donate the hydroxyl ion. Similarly, in a Bronsted and a Lowry theory, we have understood that acid is a substance which will donate the hydrogen or H plus ion, or base is a substance which accepts the H plus ion. But here, the Lewis, he has given the new idea for the defining the acids and bases, and he told that the entire definition in terms of electron. So, according to him, what is an acid? Acid is a substance which can accept the pair of electron, where base is a substance which can easily donate the pair of electron. We will take up an example. Here you can see that the beryllium tetrafluoride with ammonia. So, here you can see that if I write this example, so how many fluoride atoms will be there? There are 3 fluoride atoms will be there. Okay. Plus ammonia, that is NH3. Correct, no? So, here you can see that these two are, when they react themselves, they form a BF3 NH3 bond. Correct, no? So, here you can see that the beryllium tetrafluoride, so which are accepting the electron. Correct, no? It is getting accepting the electron. Hence, it is an Lewis acid. What is it? It is an Lewis acid. Since our ammonia is donating the pair of electron, hence it is an Lewis base. Okay. Thereby, it forms a bond between the two molecules. This is how, he defined an acid and bases by taking an example. So, what is the acid? Acid is a substance which can accept the pair of electron, where base is a substance which can accept the pair of electron. So, in the above example, the ammonia is going to donate the pair of electron, hence it is an base. Whereas, BF3, that is boron trifluoride, is going to accept the pair of electron, hence it is a Lewis acid. This is how he defined a acid and bases. Hope you all understood with the three different theories of acid and bases. One is Arrhenius theory, another one is Bronsted-Lowry theory, and the last one is Lewis theory. In all this theory, you should have the knowledge of defining the acids and bases, and it is very important for the examination point of view. Next, we will solve the sum of the numerical based upon the equilibrium constant, that is Kc. The first one, the following concentrations were obtained for the formation of ammonia from nitrogen and hydrogen at equilibrium at 500 Kelvin. The molar concentration of nitrogen is 1.5 into 10 to the power of minus 2 molar, and the molar concentration of hydrogen is 3.0 into 10 to the power of minus 2. Similarly, the molar concentration of the ammonia they have given, it is 1.2 into 10 to the power of minus 2 molar. Calculate the equilibrium constant. So first we will see how does the nitrogen and hydrogen they form a equilibrium state by forming a ammonia. Okay. First I will write the equation. Okay. That is nitrogen, hydrogen, when they react themselves, they form a ammonia. In order to balance this equation, I will write the reaction coefficient or the stoichiometric coefficient, which is at equilibrium at 500 Kelvin. Now we need to calculate the equilibrium constant, that is Kc. So for this reaction, the Kc can be written as the molar concentration of the product. What is Kc? It is nothing but a molar concentration of the product divided by molar concentration of the reactant. So NH3, so the stoichiometric coefficient is 2. Similarly, the concentration of N2, that are the reactant, and concentration of the hydrogen is H2 raised to the power 3, because the stoichiometric coefficient are 3. Now I will substitute the values here. So what is the molar concentration of the ammonia? It is 1.2 into 10 to the power of minus 2 whole square divided by, what is the molar concentration of the nitrogen they have given? 1.5 into 10 to the power of minus 2 into, what is the molar concentration of the hydrogen? It is 3.0 into 10 to the power of minus 2 whole to the power 3. Okay. Now, if you multiply 1.2 into 1.2, you will get 1.44 into 10 to the power of 2 2s are 4. So, it is minus 4 divided by 3 3s are, it is nothing but 27. So, it is 1.5 into 10 to the power of minus 2 into 27.0 into 10 to the power of 2 3s are 6. Okay. Now, if you do it, 40.5, I'll write it here. Okay. So, it is 1.44 into 10 to the power of minus 4 divided by 40.5 into 10 to the power of minus 2 into 10 to the power of minus 6 is 10 to the power of minus 8. Now, if you divide 1.44 divided by 40.5, you will get 0.0355 and 5. So, 0.335 we will get it just by dividing 1.44 divided by 40.5. When the 10 to the power of minus 8 which goes to the numerator, it will become plus 8. So, minus 4 into 10 to the power of plus 8 will become 10 to the power of 4. Now, I can shift this point and I can rewrite this. So, I am just shifting the point and I can rewrite this as 3.55 into 10 to the power of 2. So, it is 3.55 into 10 to the power of 2. This is how we will do the calculation. It is a simple calculation to calculate the equilibrium constant. So hope you all understood with this. We'll take up one more numerical. At equilibrium, the concentration of nitrogen is 3.0 into 10 to the minus 2 molar and oxygen is 4.2 into 10 to the minus 3 molar and nitric oxide is 2.8 into 10 to the minus 3 molar in a sealed vessel at 800 Kelvin. What is the Kc for the reaction? Here, the reaction they have given. What is the reaction they have given? So, nitrogen plus oxygen will be is in equilibrium to give 2 NO. Correct, no? And all are in the gaseous state. We need to calculate what? Kc. So, what is the Kc here? Kc is nothing but the equilibrium constant. Again, we need to calculate the equilibrium constant for this above equation. So, what is the Kc? So, Kc is nothing but a molar concentration of the product divided by molar concentration of the reactant. So, it is molar concentration of the product is nitric oxide raised to the power of 2 divided by molar concentration of nitrogen into molar concentration of oxygen. Now, if you see that they have given the molar concentration for the each compound for NO, that is 2.8 into 10 to the power of minus 3 whole to the power of 2. So, this is a value. Similarly, they have given the values for nitrogen as well as with the oxygen. I'll consider the molar concentration of the nitrogen is 3.0 into 10 to the power of minus 2 into molar concentration of oxygen is 4.2 into 10 to the power of minus 3. Now, if you multiply, you will get 7.84 into 10 to the power of 3 2s are 6 divided by 3.0 into 4.2 is 12.6 into 10 to the power of minus 2 and minus 3 is nothing but a 6. Now, I will divide 7.84 divided by 12.6. You will get how much? 0.622. So, this 10 to the power of minus 6 when it comes to the numerator, it will become 10 to the power of plus 6. So, plus 6 and minus 6 will get cancelled out. So, you will get 0.622 as an answer. So, hope you all understood how to calculate the Kc for the given reaction. We will take one more numerical. PCl5, PCl3 and Cl2 are at equilibrium at 500 Kelvin having the concentration of 1.59 molar PCl3, 1.59 molar Cl2 and 1.14 molar PCl5 and calculate the Kc for the reaction. So, what is the reaction they have given? PCl5 is at equilibrium to give PCl3 plus Cl2. Now, I will write the equation. PCl5 is at equilibrium to give PCl3 plus Cl2. Now, if you see that this is a reactant which will undergo decomposition process to give PCl3 and Cl2. We need to calculate what? Equilibrium constant, that is Kc. So, Kc will be obtained by molar concentration of the product. So, for the PCl3 they have given 1.59 and also for the Cl2 is 1.59. So, same they have given, correct no? So, I can write 1.59 whole square divided by PCl5. What is the value they have given for the PCl5? It is 1.41. Now, if you multiply, you will get 2.5281 divided by 1.41. So, if you divide this, you will get 1.79. This is how we can easily calculate the equilibrium constant by looking at the molar concentration of the product as well as with the molar concentration of the reactant. So, hope you all understood with this numerical. We will take one more numerical because all the first three numericals are one and the same. Just by looking at the reactant molar concentration and molar concentration of the product, we can easily calculate the Kc. Now we'll take up the different numerical. Let's see how to solve this. Okay. For the equilibrium of 2NOCl is at equilibrium with 2NO plus Cl2. The value of equilibrium constant Kc is 3.75 into 10 power of minus 6 at 1069 Kelvin. Calculate the reaction at this temperature. So here they have already given the equilibrium constant, that is Kc value they have given. We need to calculate what? Kp value, that is the reaction at that particular temperature. So we have the relationship with the Kc as well as with the Kp, that is Kp is equal to Kc into RT raised to the power of delta Ng. Correct now? And we know that delta Ng, the delta Ng is obtained by number of moles in the product which is in a gaseous state minus number of reactant in the gaseous state. So how many products are there here? So you can see that it is 2 and 1. So it is 2 plus 1 minus how many reactants are there? 2. So it is 3 minus 2. It is nothing but a 1. And they have given the temperature and we know that what is the gas constant value also, and they have given the Kc value. We'll apply now. So what is the Kc value they have given? So it is 3.75 into 10 to the power of minus 6 into what is the gas constant value? That is 0.0831. And what is the temperature they have given? At 1069 raised to the power of 1. So anything raised to the power 1 means it is the same. So if I multiply this, so you will get Kp value as 0.00333. Or if you shift the point, you can rewrite the Kp also as 3.33 into 10 to the power of minus 4. Okay. This is how the relationship between the Kc with the Kp can be easily calculated by looking at the numericals. Hope you all understood with this numerical. So if you look at this problem, the value of Kc for the reaction is 2A is at equilibrium with B plus C is 2 into 10 to the power of minus 3 at the given time. The composition of the reaction mixtures are A, B, C are equal to 3 into 10 to the power of minus 4. In which direction will the reactions are proceed? So here we need to calculate what? Reaction coefficient, that is Qc. And we know that Qc will be obtained by the molar concentration of the reactant, that is B into molar concentration of the C divided by molar concentration of the A, that is nothing but a reactant raised to the power of 2. Okay. Now we know that the molar concentration of A, B, C are equal to 3 into 10 to the power of minus 4. So I'll write 3 into 10 to the power of minus 4 into 3 into 10 to the power of minus 4 divided by 3 into 10 to the power of minus 4 whole square. Correct now? So 3 into 10 to the power of 4 and 3 into 10 to the power of 4 will get cancelled with each other and it is equal to 1. So by looking at the Qc value, it is understood that the Qc value that is equal to 1, and you can see that it is greater than the Kc value. What is the Kc value they have given? That is 2 into 10 to the power of minus 3. It is nothing but a 0.002. So I can write that is greater than Kc because the Qc value is 1 and it is nothing but a 0.002. Okay. That is why Qc is greater than Kc. And also they have given one more question, in which direction the reaction is proceeding. And if the Qc value is greater than Kc, we have already understood that the reactions will be proceeding in a reversible manner and it is nothing but a backward directions. So hope you all understood with this numerical. We'll solve the last one. Find the value of Kc for the following equilibrium from the value of Kp. So they have given the two numerical, you need to calculate the Kc value. Okay. 2NOCl is giving rise to 2NO plus Cl2 and Kp value they have given. Okay. So what is the relationship for the first one? I'll solve first. Okay. So that is 2NOCl is going to give 2NO plus Cl2. Okay. Now if you see this reaction, they have given the Kp value, correct? No, we have a relationship that is Kp is equal to Kc into RT raised to the power of delta Ng. Now they have given the Kp value, we need to calculate the Kc value, correct? No, so the Kc will become Kp divided by RT raised to the power of delta Ng. So what is the delta Ng here? Delta Ng value is nothing but a number of moles of the product divided by number of moles of the reactant in the gaseous state. How many moles will be there? Here 2 plus 1, it is 2 plus 1 minus 2, correct? No? So it is 3 minus 2, it is equal to 1. So what is the Kp value they have given? It is 1.8. 1.8 into 10 to the power of minus 2 divided by what is the R value? It is 0.0831 into what is the temperature they have given at 500 raised to the power 1. Anything raised to the power will be equal to 1. Just multiply the 500 with a 0.0831. So you will get 1.8 into 10 to the power of minus 2 divided by 41.55. Now you divide 1.5 divided by 41.55. You will get 0.0432. 0.0432 into 10 to the power of minus 2. Now if you shift this point and you can rewrite this as 4.32 into 10 to the power of minus 4. So you can rewrite like this also. What is the answer? So the answer is, for the first question, it is 4.32 into 10 to the power of minus 4. CaCO3 in the solid state will be decomposed to give CO plus CO2. So one is at a solid state, one is at the gaseous state. So what is the relationship we have? Kp is equal to Kc into RT raised to the power of delta Ng. We know that we need to calculate the Kc here. So Kp divided by RT raised to the power of delta Ng. So what is the delta Ng says? It is nothing but a number of moles in the product side divided by number of moles in the reactant side, and that should be in the gaseous state. If you see the product, one is at the solid state, one is at the liquid state. It is 1, okay, because it's not applicable for the solids. In the product side, if you see that, you'll get in the solid state only. So it should be in the gaseous state. I'll put 0. So it is equal to 1 only. Now if you see the Kp value for this reaction, it is 167 divided by what is the R value? 0.0831 into what is the temperature they have given? It is 1073. If you multiply 0.0831 into 1073, you will get 89.1663. Now you divide 167 divided by 89.1663, you will get 1.872. How much you will get? 1.872. This is how for the second question you will get 1.872 as a answer. Okay. This is how, for the given reaction, we can easily solve the numerical. So, hope you all understood with the first and the second question in the sixth question. Okay. In the next session, we are going to discuss with the ionization of acids and bases. So, hope you all understood with this class. It is more about the numerical. Please, while solving the numerical, practice with writing so that you will understand how to solve the numerical. I'll come back with the next session. Till then, take care, be safe. Thank you.